Have you ever wondered about the different layers of the sun and their temperatures? It's truly fascinating. As the largest object in our solar system, the sun's enormous energy drives life on Earth. But did you know that this blazing ball of gas is made up of several distinct layers? Each layer is a world unto itself, with unique characteristics and temperatures that defy comprehension. From the scorching core where hydrogen turns into helium, through the mysterious radiative and convection zones, to the various atmospheric layers like the photosphere, chromosphere, and the enigmatic corona, our sun is a cosmic furnace like no other. So are you ready to dive in and explore the sun's fascinating layers? Let's go. The sun, a 4.5 billion-year-old star, is a complex entity. It's far more than just a glowing ball of light in our sky. It's a multi-layered marvel of cosmic engineering, each layer with unique characteristics and functions that keep the sun burning brightly. Starting from the inside, we have the core. This is the sun's powerhouse, where hydrogen atoms collide and fuse together to form helium, releasing an immense amount of energy in the process. It's a sizzling hotbed of activity, with temperatures reaching a staggering 27 million degrees Fahrenheit, or 15 million degrees Celsius. Surrounding the core is the radiative zone. Here, energy produced in the core travels outward in a kind of cosmic game of pinball, bouncing off particles in a process known as radiative diffusion. This zone acts as a buffer, slowing down the outward movement of energy and keeping the core compact. Next, we have the convection zone. In this region, energy gets transported upwards by giant convection currents, much like the bubbling of a boiling pot of water. These movements give rise to the sun's granular appearance when viewed up close. Now, stepping outside into the sun's atmosphere, we first encounter the photosphere. This is the layer we see as the sun's surface. It's here that the light generated in the core finally escapes into space. The photosphere is much cooler than the core, with temperatures around 10,000 degrees Fahrenheit, or 5,500 degrees Celsius. Above the photosphere lies the chromosphere, a layer that emits a reddish glow and is most visible during a total solar eclipse. And finally we reach the corona, the outermost layer of the sun's atmosphere. Mysteriously, the corona is hundreds of times hotter than the surface, reaching temperatures up to 3.6 million degrees Fahrenheit or 2 million degrees Celsius. The reason for this is still a subject of ongoing research. Each layer, with its unique characteristics, plays a vital role in the sun's functioning. From the energetic core to the mysteriously hot corona, the sun's layers stand as a testament to the fascinating complexities of our universe. The sun's temperatures are a hot topic, quite literally. Let's dive in to explore the thermal mysteries of our solar system star. The sun, a colossal sphere of hot plasma, presents a fascinating temperature gradient across its layers. At the heart of the sun we find the core, the source of the sun's incredible power. Here, the temperature reaches an astounding 27 million degrees Fahrenheit. This extreme heat fuels nuclear fusion, where hydrogen atoms collide to form helium, releasing tremendous energy in the process. Moving outward from the core, we journey through the radiative and convective zones, where the temperature gradually decreases. By the time we reach the sun's surface, or the photosphere, the temperature has cooled to a comparatively mild 10,000 degrees Fahrenheit. But don't be fooled, this is still twice as hot as the hottest lava on Earth. The temperature puzzle doesn't end here. As we venture out into the sun's outer atmosphere, we encounter an intriguing anomaly. In the corona, the sun's outermost layer, the temperature paradoxically skyrockets to between 1.8 million and 3.6 million degrees Fahrenheit. That's hotter than the surface of the sun itself. This coronal heating problem is one of the most enduring mysteries in solar physics. Why is the corona hotter than the surface? What processes are at play here? To answer these questions, NASA's Parker Solar Probe is currently orbiting the sun, investigating this temperature discrepancy. These temperature variations are crucial for the sun's processes and the solar system's energy dynamics. The heat generated by the sun's core powers the fusion reactions that light up our star, while the temperature differences between the sun's layers drive solar wind and other solar phenomena. Understanding these temperatures is not just a matter of scientific curiosity, it's key to comprehending our star and its effects on our planet. Opening. The sun's influence extends far beyond its fiery facade. You might find it surprising to know that the sun's energy doesn't heat the Earth's surface uniformly. Instead, it varies, influencing our climate and regional temperatures. This is why we experience different seasons, and why some regions have a tropical climate while others are frozen tundras. The sun's atmosphere also plays a crucial role in determining the angle of solar radiation. This angle, in turn, affects seasonal temperatures at different latitudes. For instance, the equator receives direct sunlight for most of the year, resulting in consistently high temperatures. In contrast, the poles receive sunlight at a more oblique angle, leading to colder climates. But the sun doesn't just affect our weather and climate. Its energy is essential for all life on Earth. From the smallest microorganism to the largest mammal, every living creature relies on the sun's energy, either directly or indirectly. The sun's energy drives photosynthesis, the process by which plants produce food. This process forms the foundation of the food chain, supporting a wide array of life forms. In fact, without the sun, life as we know it would cease to exist. Beyond its role in supporting life, the sun also influences technological aspects of our lives. Solar energy, derived from the sun, is a renewable source of power that's increasingly being harnessed to meet our energy needs. Moreover, solar activity can affect satellite communications and navigation systems, demonstrating the sun's far-reaching influence. The sun's influence on Earth is profound, affecting not just our climate but also our daily life. Scientists tirelessly study the sun, our closest star, to unravel its mysteries. This glowing ball of gas is not just a bright spot in our sky, but a complex celestial body with secrets yet to be fully understood. Our pursuit of knowledge takes us deep into the layers of the sun, each with its unique characteristics and temperatures. One of the most intriguing research endeavors is the mission of the Parker Solar Probe. Its task is no less than to investigate one of the most baffling phenomena in solar physics, the corona's temperature discrepancy. Despite being the sun's outermost layer, the corona reaches temperatures of up to 2 million degrees Celsius, significantly hotter than the sun's surface. Why this happens remains a mystery, a riddle that the Parker Solar Probe aims to solve. Another area of intense study revolves around the sun's nuclear fusion process. Within the sun's core, hydrogen molecules collide and form helium, releasing an immense amount of energy. This energy not only gives the sun its heat, but also makes life on Earth possible. Scientists are keen to understand this process in detail, as it holds the potential for unlimited, clean energy. Understanding the sun's temperature and energy is also critical for comprehending Earth's climatic conditions. The sun's energy unevenly heats the Earth's surface, creating air currents and influencing our weather patterns. By studying the sun, we can gain valuable insights into our own planet's climate and prepare for changes in the future. In essence, every research study conducted on the sun is not just about understanding our closest star but also about understanding our place in the cosmos. It's about realizing how deeply connected we are to the universe and appreciating the intricate balance that allows life to thrive on Earth. Scientific exploration of the sun is a doorway to understanding our place in the cosmos. Our journey through the sun's layers has been a hot ride. We've traversed the sun's layers from the core, radiative zone and convection zone in its interior, to the photosphere, chromosphere and corona in its atmosphere. Each layer has its unique characteristics and temperatures, with the core reaching a scorching 27 million degrees Fahrenheit, and the surface a comparatively cooler 10,000 degrees Fahrenheit. Important facts like the sun's influence on Earth's climate and regional temperatures, and the role of solar radiation angles were also highlighted. We delved into research studies aimed at comprehending solar activity and its impact on Earth. This radiant journey underscores the significance of the sun, not only as the primary energy source for our planet, but also as a key player in driving our climatic conditions. While we've shed some light on the sun's layers and temperatures, remember, there's always more to explore in the universe's fiery furnace.